What system of equations should we solve to find the critical points of this Lagrange function? Now, do be careful, read questions carefully. What system of equations should we solve, not find the critical points? We just want to know what should we solve to find the critical points. Okay, this might be like an A part, and then in the B part we'll find the critical points. All right, let's copy down our function. F, x, y, oh no, it's not z, it's lambda. There we go. And what was it equal to? 2x plus y cubed. 2x plus y cubed plus lambda times our constraint, which was xy minus 5. All right, so there we go. Now, what system of equations do we have to solve? Well, critical points are what we need. So we need to find critical points for this function. So we just take partial derivatives, and we know how to find partial derivatives. And then we set them equal to 0. So derive with respect to x, we'll get a 2 here, plus lambda y. Okay. Derive with respect to y, the 2x can be ignored, we'll get 3y squared. And sometimes it can help to expand this out to be a lambda xy minus 5 lambda. If you're used to working that way, eventually you do so many of these you can try and do it in your head. Okay, but you don't have to. Okay, but we'll derive with respect to y, we'll get a plus lambda x. And finally, derive with respect to lambda. You can actually go through it and do the partial derivative, or you can just sort of remember the way the Lagrange multipliers technique works. When you derive with respect to your Lagrange multiplier, you're going to get the constraint function associated to it. Okay? Now, in order to find critical points, all of these have to be set equal to 0. And so these three equations are what need to be solved for in order to find our critical points. But we're not going to actually find the critical points right now. This is just the setup we need.